Alright, hey guys, this is 6.5, and it's on graphing square roots and cube root functions. So as our review, we're going to do a simplifying radical here. And if it were me and I were you, I would try to do this on your own, because this is going to be like a question on your quiz for Friday. So maybe pause it now, see how much you can get done on your own, and then come back. I'm going to go ahead and start it. So for the fourth root of 12, I'm looking for something that will, when I take it to the fourth power, will give me 12. And honestly, I think the closest you would get would be 2, and that's not going to be simplified. Like 2 can't, there's no fourth root that would go into 12 anyway. So, the 12 is going to stay inside the radical. There's no way to simplify that. For the x squared, you want to try to take as many as you can without going over. I can't take any out, so I'm going to leave x squared in. For y to the 6, you have 6 y's. I want to see how many groups of 4 I can take out. Well, I can take out one group, and that's going to leave me 2 inside. The other way you can do it is you can take 6 divided by 4. Goes in one time with a remainder of 2. So then our z's, we have 12 of those. And if you do those in groups of 4, there's 1, 2, 3 groups. So z cubed. The other way you could do is 12 divided by 4 is 3. And so that is your simplified version. Okay, so for today, we are looking at parent functions, and we're going to be graphing everything from the parent function. So the parent function for the square root is f of x equals the square root of x, and it's some of these pictures didn't come out very well. So make sure that you know that's the whole square root of x. And then it's not getting any better the way I try to draw this. There we go. And this looks like it's a negative, but it's not. It's an equal sign. So for f of x equals the square root of x, the parent function is 0, 0. When I plug in 1, the square root of 1 is 1. And then one more point I want you to plot on here is that if I plug in 4, the square root of 4 is 2. So you're going to have the ordered pair 4, 2. Because my x value is 4, I plugged it in and got 2 out. So 1, 2, 3, 4, up 1, 2. 4, 2 is an important ordered pair you want for the square root one. For the cubed root one on this side, and that is a cubed root over there, cubed root of 3. Negative 1, 1 is a good one, or negative 1, negative 1, positive 1, positive 1, those are all good. The next one I would do, the next perfect cube would be what 2 cubed is, which is 8. So the cubed root of 8 is 2. The cubed root of negative 8 is negative 2. So we're going to plug in, or we're going to put 8, 2 on our table, on our parent graph, and we're going to plug in negative 8, negative 2 as well. So 1, 2, 3, 5, 6. And those you're not really going to be able to plot on this, but on a 10 by 10 grid, they're going to be ones easy to plot. So it's going to be somewhere over here and somewhere up here. Okay? So, and I'm going to erase this over here just for, so I can add some notes. So when you're doing these, the first thing we're going to look at is if we have an a value. So we're looking at for f of x equals a times the square root of x, or for f of x equals a times the cubed root of x. And if you remember from all the rest of our parent graphing, that a does your stretching and shrinking. So if a is bigger than 1, it's going to be a stretch by whatever that value is. And if a is less than 1, it's going to be a shrink. Slash, we don't call them shrinks anymore. That's awkward. We call them compressions. I'm sorry. So they're compressions. There's supposed to be an IO in there, and it won't fit. Okay, if you have a negative, that's a reflection. Okay? So you want to take care of your reflections and your A values first and foremost, and then you can go on from there. Oh, look, see, if I would just zoom out, I could have written these correctly. Compression might not have an I in it. Reflection, 100%, it sure doesn't, but it's okay. Alright, so let's do an example. So in this one it says y equals 1/2 the square root of x, okay? So what we're going to do is we're going to take our ordered pairs, 0, 0, 1, 1, and 4, 2, and we're going to take them by a half. But here's what you're doing is you are changing the y value by applying the half to your x values. So we're going to stick with the x values that we were given. We're going to apply the 1/2 portion to it and the square root of x, and anyway, it's going to be fine. But first thing we're going to do is plot our ordered pairs. So we're going to start, our parent graph. So we're going to start by doing 0, 0, 1, 1, and 4, 1, 2, 3, 4, 2. So there's our parent graph, and you need to make sure you always draw in your parent graph. So then what we're going to do is we're going to take the same x values we just used, and we're going to take them by a half. So I'm going to get y equals 1/2 absolute value, or square root of 0. Well, square root of 0 is still 0, and a half of 0 is still 0. So when we plugged in 0, we got 0 out. That point doesn't change. So now let's move to 1, 1. So when I plug in 1, I get 1/2 the square root of 1. Well, I know that the square root of 1 is 1, so half of 1 is a half. So this time when I plugged in 1, I get a half out. So I plugged in 1 and I get a half. And the last one is 4, 2. So when we plug in 4, we get 1/2 of the square root of 4, which is 1/2 of 2, which is 1. Okay? So when I plug in 4, 1, 2, 3, 4, I get 1. So if you notice, all you're doing is changing the y values. You're taking all your y's and multiplying them by a half. The y's of your parent. So 0 I took by half, 1 I took by half, 2 I took by half. So you don't actually have to plug them in if you don't want. You can just take your y values and multiply them by whatever your a value is. Keep the same x, and those are going to be your new pairs are. So then the next thing it asks us to do is state the domain and range. So if you remember from first semester, domain is your x values and range is your y values. So our domain is our x values as I go from left to right. Well, my x values start here, and we're doing this of the red, the transformation graph. So my red graph starts at 1, and it goes on forever, so it goes to infinity. Since it includes 1, we're going to put a bracket around 1, and we always put a parentheses around infinity. And then for our range is our y values. So my ranges, we're always going bottom to top. So my range starts here at 0, and it's going on to infinity. And we include 0, so we're going to put a bracket at 0. Last thing it asks me to do is to compare it to the parent graph. So we know that since A is 1/2, that should be a compression by 1/2. If you don't put the by 1/2 part, it will be wrong. You need to make sure what you say what we are compressing by. And that is it. That is all we're doing on this one. So let's try this one. This says graph y equals -3 cubed root of x. Say the domain and range. Compare the graph with the graph of the cubed root of x. So we're going to start by writing down our ordered pairs for the normal cubed root. So we do 0, 0, 1, 1, -1, 1, 8, 2, and then -8, 2. So you'll notice on this one that this has a negative, so you can do this 2 ways. You can take the negative and do it with your compression. So when you multiply, I'm sorry, I was having a thought. So when you multiply your y values by something, or by the 3, you could also multiply by -3, and it's going to do the reflection and the stretch at the same time. Or if you want, you can do the negative by itself and then multiply them all by 3. However you want to do that, that's okay. The negative is reflecting it. So if I have a point here at 0, 0, and I have 1 at 1, 1, and then I have 1 at 8, 2, then I have 1 at -1, -1, and -8, -2. Here's my parent graph, and it makes like a little S shape. Don't forget your arrows. So what the negative is going to do is it's going to do a reflection. So I'm actually going to do this in 2 steps. I'm going to first do my reflection. And it's a reflection across the x-axis. So when you reflect something across the x-axis, your x values stay the same, but it changes the sign on your y value. So this has become 0, 0, 1, -1, -1. Oops, that should have been -1 to begin with. -1, +1, 8, -2, and -8, 2. I'm sorry, that should be -8, -2. I don't know what I was doing up here. I'm really sorry. Okay, so 0, 0, 1, -1. So this point's coming down here. This point is coming down here. This one's going up to here. And this one's going up to here. Okay? And you don't have to draw in those little arrows. In fact, I'm going to get rid of them. That was just to show you where they're moving. So the reflection, when I did the reflection, it created this graph. Okay? So now I'm going to stretch it by 3. So to stretch it by 3, we're going to take my y values and multiply them all by 3. So 0, 0 is going to become 0, 0. 1, -1. Well, I take this -1 and I multiply it by 3 to get -3. -1, I'm going to take this y value and multiply it by 3, so now I'm going to be at +3. 8, I'm going to multiply this -2 by 3 to get 6. And I'm going to take this. This was a +2. I don't know what I was doing last time. I suck today. I'm really sorry, guys. And I'd like to say that that's not normal, but that's, I mean. This one's -8, 8, -6, and this one's at -8, +6. Okay? So that's what it's going to do is it's going to take the purple and it's going to stretch it out. So 0, 0, we're still there. 1, -3, 1, 2, 3, that's going to go down there. -1, +3, 1, 2, 3, that's going to be there. Or 8, -6, 1, 2, 3, 4, 5, 6. And the other one, 1, 2, 3, 4, 5, and 6. So this light blue graph is my final graph. If you had done the negative and the 3 at the same time, you would have gotten to the final answer. You just wouldn't have had the middle purple one, and that's more than okay, however you want to get there. When it says compare it, that's your reflection across the x-axis and the stretch by 3. Those are your comparison. Make sure when you do your reflection that we say it's across the x-axis, and we say our stretch, we say stretch by 3. Last thing we need to do is domain and range, and so for our domain, that's our x values. Well, my x values go from -infinity to +infinity. And my range is my y values as we go from bottom to top. So as you go from bottom to top, since these arrows go on forever, the lowest point here would be -infinity, and the highest point would be +infinity. So my domain and range are -infinity to infinity, and then -infinity to infinity. If you go up here, something I forgot to point out is that on this slide, they tell you what the domain and the range are for the parent functions. They do it, however, in inequality notation, and we put everything in interval notation. So make sure you put them in interval notation. Okay, so now we're going to add in h and k, and if you remember correctly, h goes left and right, and k goes up and down, and don't forget that h is always opposite. So if there's a negative inside, you're actually going to the right, positive, and if there's a positive inside, you're actually going to the left, negative. The a value is still doing the same thing. When you have h's and k's and a's, always take care of your reflections and your stretches before you go left and right. Otherwise, you're going to have issues with changing your x or your y values. So example 3, we've got y equals -2 square root of x minus 3 plus 2. State the domain and range. How you do this is completely up to you. A lot of times on these, I will do them step by step. A lot of people prefer doing them all in once, okay? For our purposes, we're doing the square root of x here. So for the parent graph, square root of x, we're using 0, 0, 1, 1, and 4, 2 as our standard points. Always plot your parent graph, so 0, 0, 1, 1, and 4, 2. Okay, I am going to do the entire a value this time. So I'm going to do -2 square root of x. I am not going to be shifting it left or right yet. So when you do your a values, that just affects your y. So your x's all stay the same. Oops. And we're going to find our new y. So I'm going to take 0 times -2. Well, that gives me 0. I'm going to take 1 times -2. And that gives me -2. And I'm taking 2 times -2, which is -4. And don't be confused on these. These are coming from the y values, not the x values. So when I apply the -2 part, that's going to give me, 0, 0, 1, -2, and 4, -4. So what we've done to go from the blue to the purple is we have done a reflection and we have stretched it by 2. Okay? Now that we have that graph, now I'm going to apply my h. So my h value is technically 3. Even though it says -3, it's always the opposite. So my h value is 3, which means I'm going to go to the right 3. I'm taking all the x values by 3. So it's the x values that are going to the right 3. So I go 1, 2, 3, 1, 2, 3, 1, 2, 3. And our y values didn't change. Just the x values. Okay? So that was our shift right 3. And then for our last one, we're going to go the +2. So k equals 2. So that means I'm going to go up 2. And this is your y values changing. So in this case, the x values are going to stay the same, but our y values are going to go up 2. So 1, 2, 1, 2, 1, 2. So sometimes a lot of people will ask, well, how do I know if it's my x values or my y values that are changing? If it is not under the radical, if it's not grouped with that x, it affects the y's. So see the -2 and the +2 on the outside, those are all outside the radical, so those affect your y values. The -3 is inside with the x underneath the radical, so it's affecting the x values. Okay? So we've now gotten our pink graph as our final graph, okay? And now we need to do domain and range. So your domain is your x values. Well, my x values start right here at -3. And they're going to go on forever because that's an arrow. It says it goes on forever, so we're going to infinity. For my range I'm going from bottom to top. So see, this arrow says that we're going all the way on forever to -infinity. So my range actually starts at -infinity. And it stops when I get to this y value here. And that y value is 2. It is important that you write that as -infinity to 2 and not 2 to -infinity. Because we always go bottom to top. When you write 2 to negative infinity, that tells me that your starting point is 2. And on a number line, you cannot go from 2 to negative infinity. We don't go that way on a number line. So you have to go smallest to biggest. The smallest number is negative infinity. The biggest number there is 2. Okay, last example. We have y equals 3 times the cubed root of x plus 4 minus 1. So I'm going to start with my parent graph. And since I've done parent graphs in blue every time, I'm going to stick with that. So it's the cubed root graph. So my parent graph is 0, 0, 1, 1, negative 1, 1, 8, 2, 8, negative 2. Negative 8, negative 2. So 0, 0, 1, 1, 8, 2, negative 1, negative 1, negative 8, negative 2. Okay, so the first thing we're going to do is apply the stretch by 3. So stretch by 3. And that is affecting the y value. So I'm taking every y value and I'm going to multiply it by 3. So for 0, 0, I take the y value 0 times 3, which is still going to give me 0. So I'm still at 0, 0. For 1, 1, I'm taking the y value 1 and I'm multiplying it by 3. So I get 1, 3. For negative 1, negative 1. God, I really can never get that right. Negative 1, negative 1. I take the y value negative 1 and multiply it by 3 to get negative 3. For 8, 2, I'm taking the 2 and I'm multiplying it by 3 to get 6. And for negative 8, negative 2, oops, I'm sorry. I'm taking the negative 2 and I'm multiplying it by 3 to get negative 6. So now to do my stretch, I've done 0, 0, 1, 1, 2, 3, 8, 6, negative 1, negative 3, negative 8, negative 6. Okay, so that's your stretch by 3. So now I'm going to do my plus 4 inside. So that's a shift right 4. Oh, I'm sorry. H is actually negative 4. So it's a shift left 4. And again, this is changing my x values, not the y. So I'm taking all my x values and shifting them over 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Don't forget to write arrows on all these. Okay, so we shifted it over 4. And the last thing we're going to do is our shift down 1. So k is negative 1. So this is going to be a shift down 1. So all my y values are changing by 1. So I'm dropping this one to 1, dropping this one down 1, this one down 1, this one down 1, and this one down 1. So the light blue is your final one. Okay? And you can eliminate all the rest of them from your graph. You don't have to do all the rest of them. However you want to do that, that's up to you. Okay? I honestly think it's easiest to do the A and put that one on there and then shift left and right and up and down in the same step. But that's honestly up to you. Last thing I want to do is domain and range. So my domain, if I go from left to right, I've got arrows on both sides. So it's going from negative infinity to a positive infinity. And for the range, again, arrows going both ways. So negative infinity to positive infinity. And that is it. You need to get your homework from the sub if you are done. And work on this quietly for the rest of the hour. Have a good day.